Welcome students. In previous class we have discussed about distance, displacement, speed, velocity and velocity time graph, distance time graph, acceleration time graph, and we have discussed from graph uh, from slope of the graph what we can achieve, and from the area of the graph what we can achieve. Okay. So today we will discuss about the law of kinematics, basically equation of motion of kinematics. Okay. There are three equations are there. One is v equals to u plus at, s equal to ut plus half at square, and v square equal to u square plus 2s. We I think you know all the notations, that v is the final velocity, u is the initial velocity, a is the acceleration, and t is the time, s is the displacement or distance. Okay. In case of scalar form, these are written as scalar form, and you can also write as vector from v equals to u vector plus at vector, a vector into t. Okay. So s vector equals to ut plus half at square, or v square u square to a dot s. Okay. You can write it that way, as v square and u square as the square of a vector becomes a scalar. Okay. And uh, also we can prove these three equations from two way. One is by the method of graphical method, another is alternative normal method. Okay, algebraic method. So then vertical method, in graphical method, suppose we have taken velocity time graph. Okay, and from velocity time we know the definition, according to definition of acceleration, that v minus u by t. Okay, and which is the slope of this curve, velocity time graph. Okay, suppose initial velocity u, and with for constant acceleration we know the velocity time graph will be straight line. Okay, then we can get v equals to u plus at. And distance travel, we know the area of the under curve, and from this curve the area of this rectangle and area of this triangle is the area under curve, and from that we can get s equal to ut plus half at square, and v square equal to u square plus 2s. Also the distance travel is equal to area of trapezoid OABD, and we can prove. And here, to prove v square equal to u square plus 2s, here the t, suppose from this equation a equals to v minus u by t equals to v minus u by a. This t is put here, s equal to half into, suppose s equal to ut plus half at square. Then from that equation you can put that uh, value of t, and then you will get this relation v square equal to u square plus 2s. And there are also alternative methods, simple alternative. You can prove this by using simple alternative method. Okay, and these are some questions here given. You can see or practice this exercise. Okay, these are very easy problem. Okay, now I am moving to the next chapter, NLM, Newton's law of motion. Okay, so law of motion means Newton, we know that the great scientist, and who first find the law of gravitation also. Okay, so kind of force is a physical quantity. If we apply this on a body, the body can change its state, means from rest to motion, or from rest motion to rest, we can change their state of motion. Okay, and here we have to know the different type of forces. The force which act on the body when they are in physical contact are called contact force. Okay. When a body move over rough surface, a force act on a body in direction opposite to the motion of the body along the surface of contact. This is called friction force or force of friction. Okay. When a person moves towards the right on the road, and the force of friction act him towards the left, and force resist his motion on the road. When a body placed on surface, the body exerts a force equal to the weight downward direction of the surface. Yes. However, the body does not move or fall because the surface exerts equal and opposite force on it, which is called normal reaction. Suppose this is a table, okay, and an object is placed on it. That means object is applying force on table, okay, and also this table also providing equal and opposite force. That's why the object is not falling down. Okay, so this force is called normal reaction, and normal reaction is the here weight of the object. Okay, so when a body is suspended by a string, then here another type of force is there called tension force. So tension and normal reaction are the very important forces which is very much applicable. Its applications are very much here. Okay, so tension is developed here. Tension means the string. This tension is coming due to the intermolecular motion. Sorry, force between the molecules of string. Okay, this tense force is called tension. Okay, so here tension, the W weight, the object of weight W is hanged by a string. So the tension of string is now W. Tension is a force and W also a force. Weight is a force. Okay. In case of spring, if you stretch the spring by applying force, then spring also trying to reconstruct or return to its initial state. And this force, which is opposite to the applied force, and these forces are also, it has a name called a restoring force, which this force is trying to restore the spring to its initial state. Oh, so here written that the spring has tendency to return its original state. Similarly, when one end of the spring is kept fixed, the spring is found to exert a force at its other end, which is directly proportional to the displacement. When two bodies collide, they push each other and result equal and opposite force act on each body. Here written that two bodies are colliding each other and one body, whatever amount of force applying by or exerts by A on B, and equal and opposite amount of force is exerted by B on A. And what are the non-contact force? Non-contact force means the force expressed by the body without being physical touch. Suppose force between two magnets, gravitational force between sun and earth or earth and moon, okay, between the planets and satellites also. And earth and we are also attracted by the earth. This force is also non-contact force. In universe, each particle attracts another particle because of its mass. This force of attraction is called gravitational force. You know the gravitational force first discovered by with Sir Isaac Newton. Uh, he sat under an apple tree and apple was fallen on his head. The force on a body due to the earth attraction is called force of gravity. The cause the movement of body towards the earth. That means downward. The body is free to move. The body also attracts earth by equal amount of force. Okay. So the earth is attracting us and we also attracting the earth equal and opposite amount of force, but mass of the earth is very high, so we are moving towards earth but earth not moving towards us. Okay, we are moving towards earth but earth is not coming towards us. Okay, because earth is very high much than us. Okay, huge mass. Two like charge repel, we know two like charge repel each other and unlike charge attract each other. This force of called electrostatic force. And two like magnet repel each other, unlike magnet. This is called magnetic force. Okay, these are the some examples of forces. Okay, and general characteristics of non-contact forces. The gravitational force is always attractive. This is the non-contact, but electrostatic, and magnetic force may be attractive or sometimes they are repulsive. Okay. So now the law of forces. We know Newton given three laws. Okay. The first law is if the body in a set at rest, then it will remain at rest, and if the body in set at motion, then it will continue to move with same velocity in same direction unless an external force is applied on it. The property of object virtue of which neither change its state nor tends to change its state is called inertia. What is inertia? This is important. What is inertia? The tendency of body to, by virtue of which it neither change its state or not tends to change its state is called inertia. A force is external cause which tends to change the state or rest or state of motion of an object. Okay, this is called force. So mass is the measurement of inertia of the body. Now, greater the mass, greater the inertia, and thus the more the resistance to change its state of motion. Okay, state of motion or state of rest or motion. Okay. So mass is the measurement of inertia. Inertia means the ability to set or keep its state of rest or in motion. Okay, and there is more inertia. I have told there is two type of inertia. One is inertia of rest and inertia of motion. Okay, and linear momentum is the term. Momentum is the term so that the more momentum means more force is required to stop the moving object. You can say. Okay, this is called linear momentum. Linear momentum basically multiplication of mass and speed or velocity. Okay, high mass body with small velocity, we need more amount of force to change its state, and also the body with low mass or light body but with high speed, also we need more force, resistive force to, or more force to change its state. Okay. So momentum is the body defined as the product of mass and velocity. So a body is at rest, then momentum will be zero. Momentum is vector quantity. It has the direction, which is direction of the velocity. Okay. P vector, you can write m into m is scalar quantity, but v is vector quantity. Okay. Change in momentum, we know change in momentum means change in velocity into mass. And rate of change of momentum is called change in rate of change of momentum means change in velocity per time. Change in momentum per time. This is v minus m into v minus u by t, and we know v minus u by t is the acceleration m into m. So rate of change of momentum is ma, and this is the measurement of force according to Newton's second law. Okay. So Newton's second law is that the F equals to ma, or rate of change of momentum is equal to or proportional to the force on object. And we know that SI unit of force is Newton, CGS unit is Dyne, and 1 Newton equal to 10 to the power 5 Dyne. So you can write the Newton's second law by this relation also, that the rate of change of momentum of a body is directly proportional to the applied force and take place in the direction in which the force acts. Okay, and Newton's third law we all know. Okay, the every reaction there is an equal and opposite reaction. In an interaction of two objects, there are action and reaction force present. The action and reaction force act on two different bodies. And universal law of gravity, Newton given that F equals to gmm by r square. We all know g is the gravitational constant. Okay, the unit of g is Newton meter square per kg square, and value of g is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Okay, and force due to gravity, you can calculate for force on 1 kg object of mass 1 kg, you can calculate that 9.8 Newton. And we know the force on unit mass is the acceleration, because acceleration is the F by m. F equals to ma, and a equals to force per unit mass. And acceleration due to gravity means the when a body freely falling under gravity, its velocity increase by 9.8 meter per second per second. Okay, this is called acceleration due to gravity. And you can write that force on unit mass, we know the force on mass by the earth is g capital M small m by r square. R is the radius of earth. Uh, and the gravitational acceleration means force on unit mass. So gm into 1 by r square. Then you can also get 9.8 meter per second square. Okay. Free fall means freely falling, but the motion of freely falling body thrown vertically upward in one dimensional motion under gravity. If the body freely falling, then A equals to G, and if body thrown upward, then A equals to minus G. You can take. Okay. Mass and weight. Mass, amount of matter contained in a body at rest, is called mass. It is a scalar quantity, and weight is a force basically. Mass into G, gravitational acceleration. The force which is exerted by the earth on an object towards the center of earth is called weight. Here written that force with which an object is attracted towards the earth is the weight of the object. W equals to mg. Okay. What is the difference between mass and object? This is very much important different. It measures the amount of matter contained in body at rest. It is the force with which the earth attracted the body. So mass is the scalar, weight is the vector quantity. Unit of mass is kg and gram. Weight is Newton and dyne. Okay. The gravitational unit kgf. Kgf means 1 kg into gravitational acceleration due to gravity. And 1 gram force means 1 gram into acceleration due to gravity. This is the brief description of the chapter Newton's law of motion, and from that uh, chapter you will get some questions, some mathematical numericals, and from the second law of motion F equals to ma, or F equals to rate of change of momentum. Okay, okay, that's all for today's video. Okay, bye.